Hi there, everybody. I am here starting a video. There we go. Um, Intended to give you the directions for this assignment called Counting Atoms. This is an explanation for how to fill out this worksheet. Now, the written directions are pretty good, so you should read them separately. And since you can read those, I'm not going to explain that to you. Here we start out on the first page with a set of rules you'll use when you are counting atoms in a compound. And here we have, for example, three H2O molecules. So we have three of these molecules, and I'm going to count them each line by line and show you my math and summarize it. And here's a second example, two carbon dioxide molecules. So that should be pretty self-explanatory and will be very helpful for you. It's written down for a reason. But since you can do that on your own, I'm not going to take up time from the video. I'm going to go through a couple more problems. Now, this is what page 2 looks like, and there is 10 of these problems for you to try on your own and turn in. The first one here is two molecules of H2O. You've heard of H2O, it's water, and I'm going to show you how to count them. I then changed number 2 and number 4. So these are different from your worksheet, and kind of like I did on the ions and isotopes video. So I'll be able to give you 3 examples, but you'll only get the free answers for number 1. And when I give you my second and third example, it's just to show you the process. You can refer back to that. Maybe that'll help. So first of all, looking at this notation here for this first problem, 2 H2O molecules, the big coefficient in front here, the 2, means every single thing after it. If you're looking at a chemical equation, everything until you get to a plus sign or an equal sign. In chemistry, the yield sign is an arrow, and it's sort of like an equal sign in math. But everything between that big coefficient, the big number in front, I've got highlighted in blue, and the end of that molecule. So when you come to a plus sign or the end of the equation, or maybe if you're in the middle of it, you come to that yield arrow, everything is going to then get doubled or multiplied by 2. It's the same thing as if I typed this with parentheses like this. Same exact thing. And maybe that will help you because that will look familiar to how things are written in math. Since that chemists are too lazy to do that, I'm taking it away. Just want you to understand that the big coefficient in front means everything gets doubled. Now, normally, if that hadn't been there, there would have been 2 hydrogen. You can see the little 2, the small subscript, we say. It's a little number down low. It always refers to the element beforehand. So it refers to the H, the hydrogen, not the oxygen. It refers to the element beforehand. So there's already 2 there. When I multiply that by 2 and I double that, the total here becomes 4. Oxygen, there's no subscript here. So we assume that means that there's 1 of them. There's 1 oxygen, there's no subscript, but we're going to double that, and we end up with 2. Now, if I count up all the atoms, I have 4 that are hydrogen, I have 2 that are oxygen, so the total is 6. And that's what I meant by total number of atoms. So we're counting in these 2 molecules, we have 4 hydrogen, we've got 2 oxygen, a total of 6 atoms. All right, let's move on. Now, this HNO3 is not on your worksheet. So it's just an opportunity for me to do some more and not steal from you the learning that's going to come from answering your own questions there. I've got, I should start with hydrogen. Excuse my typo there. I only see the H. I don't see any little numbers, no subscripts at all. So that means that there is only 1 of them. I have nitrogen, and I don't see any little subscripts, which means that there's only 1 of them. There's no big coefficient in front. I'm not multiplying this by anything. So I've got a hydrogen. I see it right there. I wrote down 1. I've got a nitrogen. I see it right there. I wrote down 1. Now, I have oxygen. And here, in this case, I do have a subscript. That little 3 means, that, well, before my blue highlight there, I'm not very skilled with my Chromebook trackpad. It means that there are 3 of those. Easy. So there we go. I'm now done with my counting, and I could come over here and say my total as well. Control copy. So I'm going to do that. My total is, I've got 1 hydrogen, 1 nitrogen, that's 2, and 3 more things, oxygen. My total is 5. Total 5 atoms to make these this one molecule possible. Now, I'm going to do my third example here. I have 4MgOH2. Now, I've got some new things going on. First of all, we again have a coefficient in front. There's that big 4. So basically, everything will be quadrupled. I'll multiply everything by 4. I have 4 molecules. Each molecule has 1 Mg and then has this parentheses OH2 thing going on. So I wonder if I even wrote that down correctly, but I think that I did. At any rate, we're going to solve it this way. I'm going to write down my Mg. That's magnesium. I'm going to skip ahead in here. I'm going to list my oxygen. And I'm going to then list my final element here, hydrogen. Okay, so going back to my magnesium, looks to me like I have only the 1 and I per molecule, but everything is going to be multiplied by 4. It's quadrupled. So that means I have 4 magnesium. Looking at the oxygen, I don't see any little subscript here. So I only have 1 oxygen. However, because of the coefficient, everything gets quadrupled. Oxygen goes from 1 to 4. Not a dollar sign, to 4. And my hydrogen is interesting. This little subscript means that there are 2 of them, but because of the big coefficient, everything is being quadrupled. Everything gets multiplied by 4. So 2 times 4 is going to be 8. Now, I have to total all that up. I have 4 magnesium, 4 oxygen, that's 8, with 8 more hydrogen. Total number of atoms for this compound here, these 4 magnesium oxide hydride molecules, for the total number of atoms would be 16 then. So this should be pretty easy for you to go down through and answer the rest of them here. You want to follow those same rules. If you have parentheses and then either a subscript after them or a big coefficient before them, everything inside the parentheses get multiplied by that number. If you have a subscript, if you have a little tiny number, right, that's next to or comes right after an element, it refers to the number of atoms of that element. It refers to the large symbol that comes before it. So you're going to have both of those in number 4 here. CH4 is methane. Looks to me like you have 2 methanes. You're going to have to then figure out individually. This is pretty easy. It's pretty clear how many carbon are here and how many hydrogen are there, but they're both going to get doubled because of the little subscript here, etc. So down here we have in number 5, you've got pretty clear how many calcium there are. There's no subscripts at all. Here inside the parentheses, there are no subscripts. There's only 1 of those, but the 4 gets multiplied, distributed everything inside the parentheses and only the things inside the parentheses. And again, for the oxygen, there's no subscript at all. So there's only 1 of them. So read the rules, read the examples, watch the video again if it helps, but you should find this is a pretty, you're pretty successful at this. And I wish that it goes quickly for you. Go slow enough that you feel really confident in your answers. And then this will really help as a building block for all your future work with chemical reactions. Good luck. Enjoy.